Well, it's great to be here in New York, and thanks, Tom, for the invite. As Tom mentioned, my name is Tony Ucita Velez. I go by Tony UV, just a little bit more palatable, or Ultra T on Meetup. But today I'm going to talk to you about threat modeling and this risk-centric threat modeling process that me and actually another OWASP member from London, Marco Morana, we invented this methodology called PASTA. He's a native Italian, and we came up with this acronym to basically signify process for attack simulation and threat analysis. So I wrote this book with Marco Morana about last year, and through Wiley Life Sciences here in New York, and it is really it's a two-in-one. So if you know nothing about threat modeling, half the book is about that. The other half is strictly about risk-centric threat modeling. It has use cases for different types of application types. Marco and I, we have a lot of background in healthcare, higher education, financial, government, and a lot of other industry sets. And we came together as OWASP leaders and thought, well, what is the driver for security, for securing applications? And most of the talks at the middle management up level are around, why do we need security? Why do we need to secure this? Or why do we need to take this remediation item before my functional requirement for this application? So it's about understanding the drivers or making security a little bit more relevant in discussions in corporate America. Okay, so I'm just going to whiz through a lot of this stuff. This is kind of threat modeling 101. Traditionally, with application threat modeling, if you think about it, a lot of there's all these different activities that go along with application threat modeling, like data flow diagramming, like maybe building an attack tree, or exemplifying a kill chain diagram for how an application gets compromised, a sequential linear set of events that actually attacks a given application component. And so it's very architectural driven, it's very software driven, and that's good, but there's some other types of attack vectors that we feel, Marco and I felt, that was missing. And so we wanted to look at a broader stack of potential attack vectors. And the goal really is protect what matters, and that's why we came up with this PASTA methodology. So the goal of this talk is to really introduce a risk-centric approach to doing your threat modeling. Now, one news event that I do want to share is that, so I did start this consulting firm a long time ago called VerSprite, and we've been working with DHS on automation. So there's a lot of talk. If you've seen what's going on with Netflix, and how they're doing a lot of automation with secure DevOps. It's really cool. Self-healing networks, a lot of automation and preemptive hardening on microservices, on virtualized applications. And so we're being tasked as part of a bigger group. It's really interesting, and I'd love to talk to anyone else who's interested about this, about how do you basically introduce a workflow around threat modeling. Now, the reason I bring this up is because there were some misuses of these terms that are up on the screen right now. So these are the common terms associated with threat modeling. You'll notice, countermeasure, attack or exploit abuse cases, attack vectors, attack surface actor. All of these things are part of the vernacular that goes into any type of threat modeling methodology. So let's take a step back on threats today in the world of cybersecurity, cybercrime, and one of the things that we wanted to build with a risk-centric approach is better intelligence. So context, I'm going to use that word a lot, context. So one of the things that if you use the Microsoft tool, it has a weakness library, it has a very small sample of possible threats, based upon stride, spoofing, tampering, repudiation, information disclosure, etc. And it also has other types of libraries related to possible components that you might have in your application, like name types or web services, etc. So, but threat is something that is oftentimes left out. So what we strive to do is to marry threat intel with your application. So what type of threat intelligence is out there that correlates to your application stack? And so that's important to ask yourself these questions of like, what are you seeing, what are you using, what protocols are you using in your application? And so, there's a lot of threat intel sources out there, and most of it, to be honest, is garbage. I think if you've been in the security industry, you see that it's really difficult to operationalize a lot of noise that's coming your way from millions of different places, and it's just, it's difficult to take that and effectively and apply it to your application and say, these threats are happening against Angular, against Node, against, yes?
Can you use deep learning algorithms to separate the noise?
Unfortunately, that is the multi-billion-dollar answer right there. I mean, there's a lot of different players out there in the industry that are trying to do just that. They're trying to, data analytics is coming to the has already arrived at the information security industry, but it's still in diapers. In my opinion, it's still in diapers. There's not the level of sophistication and intelligence in order to have the right, pristine, non-FUD related threats to come into you so you can make that actionable and say, this is a threat that I can correlate to my application stack, or my system stack, or my network, or my virtual computing platforms. So, when we say the word threat, there's two things that I want to talk about as it relates to PASTA and the risk-centric methodology. And I'm kind of prefacing this because we want to embrace where we can actually subscribe to different threat sources when we're doing application threat modeling. And so we want to be able to see what threat data are we originating as an IT environment. What sort of logs do we have at the system stack? Do our application developers, have they already defined good application logs to see what sort of HTTP methods and parameters are being captured for each type of get, post, put request, or whatever. So what are we monitoring? How are you logging it? How can that be used as threat data? So things that you harvest on the inside are threat data. Things that you would pull from the outside, like US CERT or the French CERT or the Tunisian CERT, or all the high trust cybersecurity exchange. Every industry basically has a threat center that you can have. So it's important that as we've evolved in criminal activities, as we see the landscape of different types of attacks, we look at going back close to 30 years ago, the different types of attacks were a lot simpler because the trust model in applications simply was a lot more promiscuous, right? The trust models, the trust models within an application, they trusted one another. Database would trust a web server. A comm service would trust back-end file system. So there was a lot of inherent trust. And so what we want to do when we factor in threat intelligence in today's world is to see what are the prevalent crimes that are happening today in the cyber market. IoT, healthcare. Again, as a consultant, I can just simply impart with you guys what I see across different industries. In per industry, you have different data models, you have different infrastructure adoptions, you have different resources, financial versus, let's say, energy, two different worlds where data is king and the other continuity is king. So you have two different types of objectives. And when you're threat modeling for applications, especially from a risk-centric standpoint, you really want to be able to understand that. All right, so I'm going to skip through this section real quick here because it really just I'm going to go into the actual process for PASTA. So like I said before, the difference between PASTA as a methodology is that it's risk-centric. It basically says, listen, we've been doing remediation as an industry for a long time. And most remediation queues are piling up. And they don't get enough because there's a limited time, limited resources. So let's remediate what matters. Let's try to understand the threats that are most viable, all right? So let's substantiate these attacks. And let's also provide some context of impact. It wouldn't be New York without a siren, right?
You don't even notice this. I wouldn't have heard it.
Yeah, that's true. So this is the methodology, 7 stages, and I'm going to get into we have a RACI diagram we can share. We have if you want to know who does what in different stages, but really quick, the first stage is something that's kind of non-traditional as security engineers or application developers or security professionals, because most of us are wired to break and show and demonstrate exploitability and stuff like that. But here we want to take a step back and understand what is the objective of this application. Is it for, is it basically an e-commerce platform to sell and to sell goods? Is it a shipping site where you're trying to queue up, different ship orders or whatnot? What is the objective, and what is the impact of downtime? What is the impact of data integrity violations in your application? Let's just stop right there for a second. Data integrity violations, because I have healthcare top of mind right now. So, obviously, you've heard of, the lawsuit that happened recently. I forgot the name of the research company that basically brought it up to the attention, and they were accused of short selling stock. But there was another disclosure where a wearable or an implantable with embedded RFID technology could be man in the middle. And when you think about healthcare, you think about the integrity of information, because you have physicians that are using electronic health records and electronic medical applications and PHI-related applications and making decisions, right? They're looking at they're looking at images, they're looking at diagnosis, prior history records, and based upon that, they're making decisions off of that. So you have to think about, when you're starting a risk-centric approach, why do I even care about this stupid application? And let me break down the functional aspects of my application, and do they help fulfill a data integrity goal? Do they help to fulfill a continuity goal? Let's say if you're a financial company and you're streaming financial stock values to different clients that are relying on those values in order to make decisions and valuations or whatnot. So you start there, and then you go into technical. We're going to cover all these in detail. So here's kind of the overview, and let's just jump in. Basically, I'm going to try to come back to this, because with the risk-centric approach, it's not about, oh, wow, do I need to hire for a threat modeling? You're leveraging a lot of if you're an organization that has a security operations group, if you're an organization that does pen testing with an external entity, or you have people that are already, eyes on glass, looking at logs like with a SOC, you have the components already to feed into a risk-centric model. It's all about orchestration, really. There's a secret of risk-centric threat modeling, I said. It's just orchestrating what's there, and so that there's greater collaboration, because as most of us could probably admit in security is very adversarial. It's me coming to you saying, hey, I just did an audit of your system and you stink, and I'm going to fail this compliance thing. Or I just, I did a pen test on your web application, and I found all these different, sandbox escaping flaws with your Angular app. So it's very adversarial. So I find stuff, you stink, fix it, and I'm going to go away. So the threat modeling is overall very collaborative, and I want to get to that, because there's definitely some added value in that. Now, in adopting any methodology, and this is truly a methodology because it is step by step on what to do and how to do it and what tools to use, there's a crawl walk process. In fact, we actually mapped a lot of the activities in the 7 stages. Each stage has like 3 or 4 different activities to BSIM or to software assurance maturity model from OWASP. So step 1, I already talked about this, is basically understanding your application, your business objectives. If you look on the screen right now, I'll let you guys look at this. There's many examples. Some of these may resonate depending upon what your background is, but I'll use one that actually happened. So one of our clients is a major hosting IP service provider, cloud hosting provider, and they got DDoS big time. First, there was an organized crime group that sent them a letter, typical extortion style, and said, hey, if you don't do this, we're going to blast you with 700 gig related traffic to all your pipes. And so they didn't do anything about the extortion, didn't pay in Bitcoin, and they got hit. And so fast forward to the end. So fortunately, they worked with partners in order to kind of do some internet scrubbing on that traffic that came in. And this is an infrastructure threat, right? So this has nothing to do with applications. But the notion of understanding what's impactful is yet the same. For this organization, continuity is king, right? They host people's applications and infrastructure and virtualized computing. And so resiliency and uptime is king. as part of a threat modeling exercise, we interviewed the sales organization to basically see what was the churn, because they had a lot of churn on customers who were like, see it, we're out of here. And then we also saw what types of opportunity costs were lost as a result of that conversations that were close to closing, but they left because of the results, and it was all over the news. So there's an impact to lack of a preemptive countermeasure or control in an application, in an infrastructure. And the question is, how well do you know that? Now, we can get very much into the weeds in terms of how do you as a security engineer, as an analyst, what information do you get as input? How do you quantify this instead of using the proverbial high, medium, low? How do you go beyond that and that sort of stuff? But along with defining objectives is this notion in stage 1 of PASTA is basically you recognize your industry set, and you might recognize certain different types of obligatory requirements that you have to have for FINRA, SEC, FedRAMP, whatever space you're in that's regulated. There's something that's probably out there that's affecting you. At the very least, it's say privacy law somewhere, right? So if your application consumes PII. So what can you preemptively do? Because a risk is, yes?
One of the great things about this approach is that, you've got a whole bunch of stuff that all of us in the security side, we immediately know what that means. But you can also, in this stage, have the conversation with a business where you can say, what could go wrong?
Right.
How could you be robbed?
Yep.
What do you not want to have happen to you? And it's really great to put this up front.
Yeah.
Because that other top level thread is oftentimes the thing that you can then play back to all the other people as you're doing it.
Right.
To identify how important, say, a funds transfer process would be compared to something else.
Exactly. In fact, I oftentimes joke around when I give these different talks. I say, as security professionals, we're really social engineering our business counterparts, because what we're doing is we're trying to understand what's important to you in making this application. To be resilient, is it the data integrity, et cetera. And so you find out what their carrots are. And then you basically, say, well, we need to bake this in. We need to bake in these security countermeasures, because if you care about these carrots, then preemptively, let's just go ahead and get them out of the way. And so usually product managers and project managers, which are the ones that are enslaving all the developers to basically work, and kind of forego these different types of requirements. Once you basically hit them up with these, carrots, as I call them, then the conversation is a lot more easier to kind of sway. So, he was just, this goes. I already talked about the kind of similar example. This is a mobile example. We'll go through a mobile example a little bit later. But the gist of this here in this CareStream, fictitious app is that this particular app is an app that is designed to help physicians liaise with big pharma, so that they can do medical studies and introduce new drugs to patients that fit the opportunity. So it's a revenue-making opportunity for a physician group, which they want to do. So they're like, yeah, sign me up, we'll get this mobile app. But there's, that's their carrot, right? So if there is abuse cases that basically deprecate the objective being met, then that's where the kind of this stage really comes to fruition. Okay. This is an interesting slide, but I'm going to go ahead and skip it because I really want to go into stage 2. But this is really about maturity and different types of threat modeling, even within stage 1. But we'll go back to that in a second. So stage 2 is really easy and really important. Do you know what you're protecting? Do you know? It really comes down to know thy assets. And there's so many different tools at the system stack, at the application stack, as a developer. So, a lot of developers, oftentimes, for major enterprise applications at least, the development is done in teams and it's broken up into different components. And now with the onset of microservices, right, and virtual cloud computing and all these different cloud-based applications, you have monolithic applications that are being decoupled into different containerized applications. So which provides even more complexity of these walls separating the understanding of interoperability and technology dependencies. The whole point of decoupling is to not have those dependencies, yes, but it's what the challenge here is that do you know what types of third-party libraries, do you know what types of frameworks you might be using that actually might be a conduit to bring down the castle? And that's basically the whole, I just summed up stage 2 right there. But basically, as you, whether you're looking at the platform stack, you're looking at physical interfaces, let's take a page from retail point-of-sale systems. Retail point-of-sale systems is really interesting right now. They're evolving, in my opinion, from traditional, embedded systems, primarily in Windows, some in Linux, like the Verifone systems, but you're also evolving to cloud-based POS. So you have all these API endpoints that are being hit up from mobile applications on tablets. So, understanding the components that are now in your mobile stack, your mobile client stack, your mobile client interfaces. A long time ago, we were doing a pen test for number 2 hamburger fast food place in the world, and they've been having their compliance-based pen testing for PCI for 5 years. And anyway, we go in there just as more of a kind of a criminalistic mindset, and we played the USB card, right? So we basically we booted up into a rogue OS, and we compromised their crypto. They had their symmetric keys on there, so we took those. We compromised hashes, of course, to all the accounts. We broke the hashes. So the point is that do you understand what might be, and that was in a lab environment. So thinking about a insert hamburger chain here on Times Square, their POS system, embedded OS. What is the probable attack vectors? What's likely to happen? It's not just about the ingress protocol coming in, to that environment. It might be another attack channel based upon, again, threat intelligence. So if there's a prevalence like Michaels, when Michaels had a vendor that was shipping out compromised hardware components that were being introduced into POS systems, and this was a long time ago, that was definitely a very unique attack vector. So what the point is, marry the threats that could happen by substantiated evidence of threat intelligence to the types of technology that you're running within your application stack. So we give off different types of examples. There's so many different, I just thought of my favorite Linux. There's this command in Linux that's awesome. So if you want it, I think it's called PIDOV. Anyone heard of it? But basically, if you're doing PSAUX and you dump it, and you want to see, okay, well, what's this PID? what's this PID that's running here? Then you can do PIDOV, and it can actually tell you what the PID is. And with sysinternals, you can basically see what types of protocols you're on a Windows machine are being used, what types of TCP or IP-based protocols are being used. Another favorite of mine is dumpcap. It's basically built into Wireshark, but it's very lean, and it allows you to actually find out if you have compromises already, because you can look at live traffic and then pull the files. If you run it through a tool like Network Miner, you can look at the Files tab and see if you have files that match a malicious hash. So there's tons of different ways, to break this down, and as long as you understand the methodology, then you can talk to your system administrators or system engineers that probably know more tools and know how to do this. So, but stage 2 is really important. It's knowing what you have. Stage 3 is application decomposition. So you're building off of stage 1, which is basically, okay, I know the objectives of my app. Stage 2 is like, I know what components I'm running. Now, how do they work together? And this is where you try to walk through a call flow of an application, and you try to understand what is the actors that are making these calls. Let's go through the CRUD exercise of create, read, update, delete of that actor in my application. What are the data flows associated with my application? And here's a mobile-based application. This happens to be a sports app, and you basically wanted to see, well, let me first start at a high level and try to understand where the trust boundaries are. I have client-side code running on my, compiled and running on my client. What sort of persistence am I baking into my mobile client? What sort of trust do I implicitly have with my web-based APIs? What sort of things require authentication? A lot of my client-side apps today, they might have a content partner, right? So this goes back to understanding your technology, because a lot of mobile apps, they will integrate with content providers. So you have a content provider that's pulling in content and rendering it to your user over a mobile UI or over your client, and that might be an attack vector for feeding in like an XSS-based attack or some sort of malvertising-based attack, as an example. So building an effective DFD data flow diagram is very important. There's different types of, here's a cloud version one, where if you're looking at the mobile client interfacing with a kind of a distributed layer virtual private cloud, in Amazon. But the idea here is that to break up the security domains of your application components, all the way from your Redis caching servers, if you're using Memcache, understanding what are they caching, what is it used for, is there any sort of like persistence of sensitive information or sessions that are being managed. So this really forces us in this stage to be good architects, and kind of question, okay, I'm making this call here as this actor with these elevated privs, and it might be bad. So stage 3 is very much an architectural exercise. Stage 4 goes all the way back to what I started. It goes about trying to correlate threat intelligence. So it's about understanding the threat landscape of your application. Where are you rolling out? Do you know your users? Do you know the threat landscape for your industry? So you begin with industry. You also then correlate threats to your infrastructure. There might be a higher prevalence of different types of, usually when criminals find a good exploit and they're selling it on the shop block and it's selling well and it's exploiting well, and there's a lot of ROI, if you will, for that exploit that they just bought, then they're going to obviously fingerprint and detect what application environments are actually running this particular framework or package or service or library or whatever. Yes?
You're going to need a lot of expertise to be able to answer these questions, correct?
Yeah.
You're not going to teach an application developer to do this.
That's true. That is a good point. That is a very good point. Yeah, because an application developer, their mantra is develop, right? So that is a very good point. And so this is where the collaborative aspect, security has to bring something to the table. So far, in stage 1, the business, the product manager, the project manager, they know the business impact. That's their mantra. They got that. Technology enumeration, usually the system engineers, the developers, they're going to be able to provide that. Here's where, as a security expert, we're going to be able to say, listen, the context of what we're protecting here is based upon these threats that are actually happening within our industry against these different types of technology sets. And that's the added value. This is where the collaboration of threat modeling is really beautiful, because it's less adversarial. It's more of a give and take.
And because you also had that conversation with the business of how could we get robbed?
Right.
They identified, don't let this happen. Many of these, the conversation with the development team can be, this is an attack. Maybe you don't understand it completely, but that would result in us getting robbed.
That's exactly right. Yeah, that's a perfect point. I'm glad you brought that up, because if we were to start out with this, then the conversation is the same as usual, right?
Yeah.
There's no different. If we were to start out with this, we're all the time saying, hey, did you hear about the latest, exploit with this or whatever? Then people are like, yeah, I get it, enough already, So it's the same old, but if you start with understanding their world, their context, and then correlate it to say, well, you're worried about that, how that could actually happen in terms of exploitation is through these ripe threats that are happening today. There's proven cases of exploitation, and actually, we'll get into the definitive aspect, because a lot of the stuff that we do in security with assessments and audits can sometimes be speculative, and that's annoying as you know what. So I don't know if I can cuss here. I'm sure Tom does it all the time. But anyway, so it's annoying, right? You know, all the different speculation of like, yeah, you know, this is a high sense of probability for exploitation, but we're getting the good thing about this methodology is that it tries to use a scientific method, and we're going to get into that. The goal. Let me just wrap up this phase here. You try to do these different types of threat trees. Bruce Schneier actually did a really good example of attack trees, but you can do threat trees as well. And threats. Let me really. This is one of my pet peeves. Let me really define threats. So, all right, I'm gonna pick on Tom, but it's in a good way. So Tom, you know, he's got a military background. He's a former Marine. So, you know, if he's got a young punk that tries to come up and step to him, then, you know, Tom might not actually be threatened. Tom might be packing something, maybe if he's in Georgia. So, you know, you have to have a certain vulnerability that is exploitable in order to feel threatened, right? Now, oftentimes people use the words threats and attacks interchangeably, and that's really kind of annoying because threats are, you know, a threat is like I want to rob a bank, or I want to steal PII, or I want to impersonate somebody, I want to break into a building in order to get, you know, a load of cash. But in order to do these threats, we have different types of attack patterns that substantiate the threat objective or the threat goal. So it's really important to kind of, you know, understand, you know, the difference of these. So this, you know, threat exercise is basically meant to try to see what threats are out there in, you know, in the industry that can correlate to our application based upon our information under management or the services we provide. In fact, I was just here in New York, and there is this. I'm not going to mention or allude to them, but they're kind of a very unique investment brokerage place that only caters to like super rich people, and they don't have a lot of clientele. But if that information were ever to get out, I mean, it would be game over. So, you know, their threat model is basically one in which if there is an association, you know, and that's what hackers are always trying to do. Hackers are trying to marry information sources. You know, they're trying to marry, I mean, obviously you guys already know that they're marrying usernames with, you know, password hashes and trying to basically, you know, try to correlate, you know, all the different dumps there are for all the different harvesting techniques that they do. They're trying to correlate it to other sources to try to identify who's who. So for this particular company, the threat is that they really want to know who these multi-billionaires are or institutional investors. So it would be important to be able to try to correlate any piece of information of services to famous people. Now, there's tons of threat sources, and there is a protocol for normalizing a schema, if you will, a data schema on threats, and you can use sticks for MITRE. It's a way that if you are organically creating threats and you want to be able to share it, there's a lot of different threat sharing platforms that are out there. There are some by industry, there are some that are more agnostic, but today, to be quite honest, there isn't really like a good API, so to speak, where you can pull down threats by infrastructure type or by, you know, by industry type or whatnot. But retail has the Retail Information Security Consortium. They have a cyber exchange. HITRUST has a cybersecurity exchange. FSI, there's an IT ISAC for infrastructure. There's an FSI ISAC for financial. All of them have, you know, threat feeds and stuff like that that can be that can at least give way to understanding threats. All right, so these next two phases, 5 and 6, are about demonstrating the viability of a threat. With 5, it's about understanding what's wrong. It's about looking at all the different use cases of authentication, authorization, session management, business logic, fraud flaws, and seeing what is weak. And again, going back to the example that I used of realizing a threat, no one typically likes to threaten something or somebody where they know that there isn't a weakness in that entity. So it's important to, and attackers are very much combing the internet and public-facing applications, as you know, for weaknesses, and they're harvesting that, and they're trying to correlate and see, you know, they're doing their generalized recon and OSINT so that they can see if they want to do a targeted attack based upon some observed weaknesses. But the point is here is that in threat modeling, we want to be able to take existing inputs from different types of testing activities that obtain weakness information, vulnerability information, in static analysis report, vulnerability reports, DAS reports, dynamic application scans, and to be able to use that as information to say what is weak with my application. Now, we marry that then with attack modeling, and this is where we exemplify the attack. So if there is a threat, and this is where we basically will have like a hierarchy of threats to attacks to weaknesses, but the intent is to demonstrate that for a given attack, for a given threat, it would be supported by 5 or 10 different attack patterns, all of which that would take advantage of a certain type, various weaknesses. Now, fortunately, there's an awesome attack library called KPEC, which many of you may have heard already. It's from MITRE, and it's a vast library. It actually comes in XML format. It also comes in PDF format. If you go to GitHub and you just do keyword search of KPEC parser, there's a couple different developers that have already begun to parse that information so that they can ingest it into maybe their security tools. A lot of the security tools that are out there do have types of plug-in capabilities like Burp Suite, as an example. So, if you want to pull down an attack library, and that attack library it matches up to your threat model, and you want to run a sequence of these attacks against your application to exemplify the viability, then that's a great way to substantiate the threats that are being covered in the threat model. So this is an example of an attack tree where you start out with, this is one threat, but so you can imagine, usually for an application you might have 3 or 4 threats, and one branch of threat would basically map to different types of attacks that would be supported by different types of weaknesses. This is a more clear rendering that I like to use, where it's basically, it looks at the target asset. And this is another healthcare look. So you have a target asset, and I think this is with an implantable, but you look at what is the asset doing, what is the use cases of the asset, so that it has that notion of objective, of that wearable, of that implantable. What is the objective of the having this implantable? What is the purpose? Then you try to you understand there's an interface to that implantable that maybe uses RFID. And you might enumerate other types of use cases that maybe is used for transferring the data when it goes to the doctor, the cardiologist. But the point is that you try to see what types of use cases are prevalent based upon actual threats, reasonable threats. And then you marry that to weaknesses that are associated with the actual product. Weaknesses in implementation, weaknesses in product design, weaknesses in third-party use, weaknesses because it's a wearable, or it's pretty much like a very limited hardware component. What would happen if it basically, goes through like if there's a computing aspect to this wearable or implantable, and it goes through a Stack Overflow, right? Because you presume that it has to use a low-level programming language and on a small hardware component where there's limited RAM, limited physical memory, and so what would be the effects of things like Stack or buffer overflows? But this representation is really good for dialogue and threat modeling discussions, because it really kind of puts together objective and target component and use cases of a product with attack patterns and weaknesses. And then ultimately, you do want to basically show what types of countermeasures. This is the. I just want to go through this. This is a common data flow diagram where you have the trust boundaries between different calls, and those arrows coming in are the different types of attacks that you could try to address. like SQL injection, file directory traversal. And the goal in doing this, like most DFDs are done on whiteboards, and the conversations are phenomenal, and they're great exercises to do. In terms of a deliverable, if you're looking for, well, what deliverable comes out of this? Well, you get more out of the actual experience of doing the data flow diagram, in my opinion, but many of the people that have implemented threat modeling into their security program, obviously they need to have a deliverable. They want a deliverable, and sometimes a DFD is a good deliverable, but DFDs can get really busy and really messy quite quickly. The last stage is simply residual risk analysis, and this basically just culminates everything that I just mentioned about, risk is a formula of, it's really about residual risk, right? You're always going to have risk. It's like, what they teach about in financial brokerage. You always have a level of risk when you invest. And in security, you're never going to be able to have a zero level of risk, but you have to have a level of risk that at least can mitigate the most viable attack patterns that support credible threats that are out there. And so this is kind of a responsible, pragmatic, yet risk-based way to look at application threat modeling. And so when we do the pen testing and when we do the actual attack modeling, we're solving for the probability of an attack, which basically supports the threat. When we look at the business context in stage one, we have some information. It'd be great if it was financial, to see what are the impacts, the adverse impacts of downtime or data contamination or privilege escalation or spoofing, stuff like that. So we want to understand the impacts for our threat trees. So ultimately, at this stage, we've architected the environment, and we have the ability to provide some prescriptive guidance to developers, to architects. Maybe the mitigation doesn't happen programmatically. Maybe because maybe we don't know the code. Maybe the mitigation has to happen architecturally, or maybe even at the network stack, layer 3, layer 4 of the OSI model. So we have to be able to. This brings in so many different constituents that support the application environment, but it's everyone can get behind a risk messaging. So it really, I hate to use the word sell as well, but it really resonates well with those that kind of partake in doing a threat modeling activity. This, I think, is my last slide. Oh, actually, so here's a RACI. It's kind of messy. I just have 2 slides. I only have a couple minutes. I want to open it up for questions. But within an enterprise, these are enterprise roles. You might have management. So there's BU product groups. Typically, a large company, like let's take one of the arms of GE, for example. They might have so many different. They might have a CIO for different lines of business. I know that different large financial institutions have different ISOs handling different wealth and investment, equity, commercial lending. So all of these different financial products are totally different, right? Their audiences are different, their data are different, their regulatory landscape might be different. So, but it's important to have a RACI model for your threat modeling activities, because this is basically your kind of your Avengers team, right? These are the team members that are going to have some level of role in doing one of the activities underneath each of the stages of PASTA. The last slide here I have is just simply a very simplistic stage of who, what, and when. Who does what, and across different stages. I think that the chapter here will probably get a copy of the slides. This is kind of a major deck, but I think it's got a lot of good information if you want to kind of leverage this and take some of this. If you have some questions around risk-centric threat modeling, the actual testing and research that me and Marco did, goes back about 7 years, and we have looked at Stride, we have looked at Trike, we looked at all the different tools, and talked to Adam Shostak a lot. We know about Residual, but this is a risk-centric approach. This is not taking away anything from the other threat modeling methodologies or approaches that are more about software design or about security-centric. We just feel that this actually also works well with agile, more iterative development because it looks at the most risk-centric related concerns around each build or each cycle that you're doing in the sprint. So that's also something to consider. But I know I saw the double hands go up, so I want to make any room for questions.
Just full disclosure, I'm a colleague of Marco's.
Oh, okay.
He's down in Florida now, but we're on the same team.
Oh, nice.
Yeah.
Cool.
So one of the things that, you know, I really liked about this, that first stage is really a thing that's missing in, you know, they're all great models, but that first stage is the thing that actually gets people to want to talk to you and listen to you.
Right.
And as you're building a threat model in this, what I found is when you have it in business terminology with some descriptions of the technology, when you do a talk to your development team to explain the threat model of this application, sometimes the eyes go wide. You know, when, let's say you're in the brokerage business and you finally get to explain to your developers that one of the major threats is one broker stealing another broker's data.
Yeah.
Or the privilege escalation of getting to the branch manager's data. And then, because you've had those conversations, it has nothing to do with cross-site scripting, it has nothing to do with terminology that may or may not be in their lexicon.
Right.
But they'll understand because of the way you start with it. So,
Yep.
you know, it's good.
Yeah, definitely. Any questions? Comments, criticisms? Yeah.
Just curious from a consultant's point of view, what level of access I guess you have in terms of bringing all these plans together? Because internally within operations, it's usually impractical.
Well, that's the sad beauty about being a consultant is that no one ever believes a prophet from their own town, as they say. And when you come in there, walking on water, you have the ability to pull in architects and developers and engineers and the network engineers and the DBAs, and then it's a fresh experience. It's a fresh voice. They haven't exactly gotten annoyed at your voice, whatever. So it's definitely an opportune time, but you got to be able to take advantage of that. And you got to be able to come in there and understand their application at all levels. And really, the best way to do it is to kind of walk in there already with the notion of these are some threats based upon what your application does. Obviously, you get some intel beforehand, and you're able to say, okay, this is what your application does functionally. This is your data, which puts you into this, compliance, black hole or regulatory hole. And I actually mind introducing at these levels of business impact. So you bring all that to the table, and then when you start talking about the data, then your DBA gets interested because he might not be doing good crypto or retention. Even something as simple as retention, where you're extending your liability of risk needlessly if your application data usage doesn't really warrant it, right? So if you're keeping everything online, but you're only really using the last month of data, then you're increasing your attack surface of data leakage for no reason, as an example. So usually these conversations with threat modeling really reveals simple stuff. And the good thing is that once you establish a good threat model for your application, you can build from there. You can mature quite quickly in terms of what you need to do in design and in terms of security requirements as part of your SDLC. And this maps very well to an SDLC. Yeah.
Another question. When would you not apply this?
I would not apply this if you were like a soft, if you were like just write, when you were like Microsoft. If Microsoft, obviously they write Word, Office products, and let's say that's all they did, which they don't. But, if you're writing just pure software, you might really, subscribe to a more software-centric approach to threat modeling because it actually might foster in other types of objectives that go beyond security and more about, improved design and code quality. So that's an area where you might not consider this. So.
Got time for one more question.
Yep.
Can you expand a little bit on the, I think you called it the behavior path first, because when I think of just grabbing something that I have to test on my own project, it's a little shady.
Yeah. Yeah, definitely, there's some shady spots there, but, you know, automation, you know, the KPEC is a tag library, so it basically, the people at MITRE have opened up this project to the community. There's a lot of consultants and people from InfoSec, application security, that have helped write KPEC what it is today. And, but it's just a huge library, and so what you, in order to kind of implement it effectively, is you want to be able to quickly identify which attack patterns correlate to your application based upon a use case string value or a particular type of framework being utilized, or you know, software components. And so you know, it's not so easy to just simply go online and to search, because I mean it's not effective. But if there's a way, and we're actually trying to develop this for this 5-year project, we're trying to basically look at the HTTP calls via an application, and look at results from different DAS and SAS, and see if we can identify application components, and then do a data mashup to KPEC. Because all of those different application components will have a weakness, and the good thing about KPEC is that it's already married to, so for an attack it tells you what weaknesses is exploited, so it's married to CWE. So the key there, you know, the key that you'll have to match on is the CWE.